Thank you, the organizing committee, for the opportunity to talk to you. I have pre-recorded my presentation, the topic of soil conservation for mitigating gaseous emissions from erosion-prone landscape. So what is soil erosion? It's a work related to transport of soil from one location to another. And the work is force times the distance times the cosine of the angle at which the force is applied. Thus, energy is involved in performing the erosion-related work. And the energy can come from different sources. For example, water, wind, gravity, chemical dissolution, tillage, harvest, and of course, brick making. As far as the water, which is the most dominant form of erosion, the energy can be raindrop impact, shallow flow, including in the irrigation channel, and concentrated flow in channels and in the tunnel, erosion, deep ravine water flow, stream bank erosion, ocean current, coastal erosion, and ice slow movement such as in glacial erosion. Raindrop impact, the major cause of erosion by the kinetic energy of the rain, mass times 1/2 mv square, and shallow flow causing the interrail erosion, or we call the sheet erosion. Rail erosion is a shallow flow on a steeper slope. Channel erosion leading to gully erosion, which cannot be mitigated by tillage traffic. Ravine erosion, which is a network of very deep gullies, which go beyond what can be mitigated through tillage traffic. Tunnel erosion, mostly in sodic soil, and the clay content where the dispersion ratio is very high, leading to serious collapse of topsoil. Coastal erosion, even the same thing as the stream bank erosion, even where the trees sometimes cannot stop the erosive forces of flowing water. The gravity erosion, typical example, landslides are different kinds of erosion, and of course then the wind erosion has several forms such as saltation, leading to dust storms. You can recognize the landmark here on September 23rd, 2009. But the dust storm have been a serious issue around the world in arid and semi-arid regions. Sand dune is a typical type of wind erosion. Therefore, a globally very, very serious problem affecting several $billion, $8 billion recent report, and 34 million tons of food production caused by erosion. The seriousness of the erosion is going to be aggravated by climate change during the 21st century. For example, the atmospheric CO2 concentration of 415 parts per million. When I was a student in primary school, it was 300 parts per million at that time in the 50s. Now it's 415 parts per million and increasing by 2.2 parts per million per year, which is primarily caused by fossil fuel combustion, but also by land use and certainly by soil erosion. Accelerated soil erosion, the second most cause of anthropogenic emissions. Now the energy use, most of it is due to fossil fuel combustion, 607 exajoule in 2015, increasing by 2.2% per year, projected to be 776 exajoule in 2040. Per capita CO2 emission in the world, about 5 megagram of CO2 per year. In the US and China, about 4 times that. And 7.8 billion people, causing that rate at the moment, going to 9.8 billion by 2050. Since 1901, Earth's temperature has increased by 0.7 to 0.9 degrees centigrade per century. but the rate of warming has doubled since 1975 to 1.5 to 1.8 degrees centigrade per century. Food insecure population because of erosion, salinization, degradation, many other social and economic issues was 821 million people in 2017, and this trend has been increasing since 2014. Soil erosion obviously has a lot to do with soil degradation. The global sediment load flux from land to ocean has been estimated at 36.6 gigaton. This does not include the delivery ratio, which is normally 10% over landscape. Therefore, this erosion on small piece of land might be as much as 10 times more. But even if you take this transport and calculate per unit area on agricultural land of 4,760 million hectare, the erosion sediment rate per hectare will be 7.7 megagram. If you modify the human-induced landscape of 66.5 million square kilometer, the average sediment rate will be 5.5 megagram per hectare. If we take the non-ice-free land, it will be 4.8 megagram per hectare. If we take total ice-free land, it will be 3.6 megagram per hectare. And you can multiply by the delivery ratio factor, and that would significantly increase the erosion rate by that process. Anthropogenic erosion is likely going to change by the climate change, especially in Africa, where it will go up between 1980 and 2090 by 36%. And globally, it will go up by 14% because of the climate change. I already mentioned the GDP change. Decrease by erosion is estimated at $8 billion per year, 33.7 million ton reduction in food by erosion, and annual sediment transport and accelerated erosion affects 24% of the total cropland area. Erosion in relation to carbon dynamics is a four-step process: detachment, breakdown, transport and redistribution, and deposition. And carbon dynamics is affected at each of these four processes, four stages of erosion. We should consider all stages together. Being a light fraction and concentrated in the surface layer, soil organic carbon is preferentially removed by water and wind, depleting the soil organic carbon concentration stock on site of erosion. Truncation of soil profile may expose the calciferous layer to acid rains and weathering, therefore leading also to CO2 emission, and the breakdown of aggregate exposes the soil organic carbon, which was previously protected from microbial processes. Now these are exposed to microbial enzymes and therefore leads to increase in the gaseous emission. Erosion is a process which is opposite of aggregation. Aggregation sequesters carbon, dispersion releases carbon, erosion causes dispersion. Therefore, soil organic carbon transported, redistributed over the landscape releases CO2 and N2O and CH4 into the atmosphere. Here is the model of an aggregate where we have begun with clay domains, which are few micrometer, and these domains lead to formation of microaggregates. By hierarchy theory, many microaggregates put together by cementing particles such as organic matter and clay put together lead to macro aggregates, and these macro aggregates are stabilized by organic molecules, which are of course carbon based. So axis representing carbon is encapsulated within stable micro and macro aggregates. If these aggregates are broken apart by erosional processes, the energy, the work being performed, disruption of aggregates, it releases carbon It exposes to microbial processes and therefore emission of gases into the atmosphere. Another way to look at this aggregation process is the soil organic matter, SOM, combining with polyvalent cation, joining with clay particle together, leading to formation of microaggregates, and X and Y macroaggregates put together lead to formation of macroaggregates, therefore carbon is sequestered. So aggregation leads to carbon sequestration. Clay particle domain, microaggregates, aggregates, beds. If this is broken apart by erosional processes, it leads from breakdown from pads to aggregate, to microaggregate, to domain and clay particles, releasing and exposing the carbon to microbial processes. Therefore, erosion is just the opposite of aggregation. This process has also high taste because it likes clay, silt, and organic matter, which are preferentially removed. Therefore, the enrichment ratio of sediment can be much higher than 1. And erosion, because of high density, leaves gravels and rocks behind. Concentration of carbon in sediments can be 1 to 40, especially in the dust storms, carrying very high percentage of carbon in the dust particles. Erosion into depletion of soil organic carbon, especially in relation to climate change, can be direct effects, such as removal of topsoil, decline in topsoil depth, selective removal of soil organic carbon, because its density is 0.6 to 0.8 megagram per cubic meter, compared with natural soil of 1.2, 1.3, 1.4 megagram per cubic meter. There are also indirect effects, such as decline in crop growth, change in soil properties, loss of nutrients and water, and many other factors which lead to change in soil structure and concentration, decline in nutrient water holding capacity, reduction in soil biotic diversity, change in infiltration rate and gaseous flux to the atmosphere, and change in soil temperature and moisture, which of course indeed impact the gaseous emission because decomposition is temperature sensitive. Albedo also is changed because of the change in the color of the soil. So all these factors do impact directly or indirectly the rate of gaseous emission from erosion-induced disruption of soil particles and exposure of carbon to the atmosphere. Therefore, on-site, depletion of soil carbon pool, disruption, slaking of aggregates, increase in gaseous emissions, exposure of calciferous horizon, and off-site redistribution of soil organic carbon over the landscape, burial of soil organic carbon in depressional sites, which can lead to methanogenesis and nitrification, denitrification process under anaerobic condition. Of course, some burial may also lead to taking carbon out of the circulation and therefore, in a way, making it recalcitrant. A schematic of a landscape where topsoil is being eroded, therefore the topsoil depth decreases where erosion is more serious on the side slope, and the carbon concentration, the carbon-rich layer increases in the place where the deposition happens. And in all these sites, there could be CO2 and N2O emission, and of course at site of the deposition due to methanogenesis and anaerobic condition, the also emission of the methane can take place. Gaseous emission also happens in the stream water, and that should not be ignored either. The delivery ratio, as I mentioned, in most cases is about 10%. Therefore, total erosion on a site of erosion is much more than what is being delivered at the point of measurement in terms of a stream. So globally, the erosion is really decoupling of the carbon in soil with that of water cycle, nitrogen cycle, carbon cycle, phosphorus cycle, and sulfur, and this decoupling aggravates the situation considerably. Consequently, some of the estimates that I made, carbon which is moved by erosional process by water is as much as 5.7 petagram per year, of which 1.1 can be emitted in the atmosphere, about 4 petagram redistributed over the landscape, and about 0.57 petagram transported into the ocean, which might be buried, but the total impact is net loss into the atmosphere. We have been talking lately about the Clean Water Act of US EPA and Clean Air Act of US EPA, but there is no Clean Soil or Clean Healthy Act anywhere in the world, including that in the United States. Therefore, I hope that your symposium, 9th European Soil Conservation Symposium, also talk about Clean Soil Act, or Soil Protection Act, or Soil Conservation Act, whatever you want to call it. We do desperately need a legal tool to protect soil resources globally, which will also have implication to gaseous emission. As I mentioned, the second largest source globally by water erosion alone, 1.1. US, I estimated 15 teragram, Brazil about 60, India about 5, 6, 7, which I think is an underestimate. I also monitored that for Iceland. We have some graduate students working there on that issue. Therefore, soil erosion cannot be, although it is being discussed as a possible sink, and I've given some references here, by the concept of dynamic replacement and deep burial, and the estimate vary considerably, but I think this concept of deep replacement certainly need to be looked at again. For UK, there was a very good paper in 2016 by Vorel et al., who estimated that for erosion to be a sink, the gross soil erosion rate must be less than 90 megagram per square kilometer per year. Eroded carbon must be completely replaced by new soil organic matter addition, and less than half of the gross erosion rate must be into the stream bank net erosion, and several fractions, particulate and dissolved organic carbon, which must be immediately buried and protected, which is not always the case, and emission of other gases like nitrous oxide and methane must also be considered in that sink source evaluation. Also, definition of erosion that we have adopted, I'm one of the authors with these two papers which are promoted by Soil Society of America, that sequestration means carbon increase in soil because of the inputs of plant from the same land unit. So if erosion is redistributing carbon to another place, it is not technically a carbon sequestration. There is also a concern about the dynamic replacement concept, because on-site productivity loss over a short period of time is a very serious issue because of loss in plant nutrients, destruction of soil structure, reduction in topsoil depth, and therefore decline in available water capacity, and crusting, compaction, and aeration problem caused, which all affect plant growth, including the change in temperature, which influences the rate of mineralization. Therefore, what are the strategies of managing erosion-prone soils, which I hope you will discuss in your symposium? Adopt erosion preventive measures, restore eroded soils, recarbonize the soil because erosion leads to depletion of carbon, and minimize both on-site and off-site effects related to gaseous emissions, non-point source pollution, and eutrophication. Education at all levels, including primary school to graduate level, and education of the policymakers and the general public, so that we can have policy intervention for example, promote rights of soil. Soil must have rights. Just like animals have rights, just like people have rights, soil is a living entity and it must have a legal rights. Human being may be able to take those who do not protect soil to court for legal action if soils have legal rights, and it must. I would like to say at the end a last statement about stewardship. This concept of stewardship for preventing erosion is a great idea, and I think we should involve religious philosophers and religious leaders in promoting that concept. But at the same time, I would like to remind you that when people are poverty-stricken, desperate, and starving, they do not care about stewardship. On the other side, they pass on their sufferings to the land. Indeed, people are the mirror image of the land that supports them, and vice versa. If you drive through poor countries, whether it's South Asia or West Africa or the Caribbean, you can see the similarity between the landscape and the standard of living of the people. On the other hand, you drive through Western Europe and North America and the Pacific countries, and you see the other way around. The people and the landscape are in good shape. And I think that brings me to the point what O. Henry brought about in very vivid writing, saying love and business and family and religion and art and patriotism are nothing but shadows of words when people are starving. Have a very nice meeting. Thank you for the opportunity to talk to you.